Hello students and welcome back to my channel. Today I have come to discuss questions based on magnetism. Okay. These questions have been picked from the 31st January both shifts, morning as well as evening shifts, 2023 JEE mains. So in continuation with the remaining 40 questions, coming to question 41, a bar magnet with magnetic moment this much is placed in parallel position related to magnetic field of this much. The amount of work done in turning the magnet from parallel to anti-parallel position related to the direction of magnetic field. Simple formula based question. We have a magnetic field here. Okay. Then uniform magnetic field is there. A magnet is placed this side south pole, this side north pole, so that the magnetic moment is in the direction of magnetic field. Whereas after turning it through 180 degree, the magnetic moment becomes anti-parallel to the magnetic field. So we have to find the work done. So work done is nothing but change in potential energy. Now see, initial potential energy is minus mb cos theta. Here theta is 0. Theta is nothing but angle between b and m. Cos 0 is 1. Whereas here final theta is 180 degree. Final potential energy is minus mb into cos theta. Cos 180 is minus 1. So change in potential energy is final minus initial, which is equal to 2 mb. So we have to substitute the values. M is how much? Magnetic moment is 5 ampere meter square. Magnetic field is zero point 0.4. Zero point 0.4 can be written as this. So this is 4 joule. And that is the work done, because work done gets converted into change in potential energy. Then moving to the next question, a rod with circular cross sectional area this much, length this much, is wound uniformly with 400 turns of an insulated wire. If a current of this much flows in the wire windings, the total magnetic flux produced inside windings is this. So the relative permeability of the rod is given, everything is given. Now you know, let me draw the diagram, rough diagram. It is a solenoid kind of a thing. Okay. Solenoid kind of a thing. And the cross section is given, everything is given. So the magnetic flux is nothing but field somewhere at the center into area. We are assuming the magnetic field to be uniform, which is just an approximation, because towards the end the magnetic field reduces. So we'll be using the magnetic field at the center formula, because we have that formula mu 0 and I. Okay, it is just an approximation. So you have to understand this, right? So here since the core is made up of some other material, you have to take the mu r also here. So phi b is how much? The magnetic flux is given as 4 pi into 10 to the power minus 6 Weber. You have to find mu r. Mu naught is how much? 4 pi into 10 to the power minus 7. Number of turns per unit length. So as you can see, 400 turns are there over a length of 40 cm. So number of turns per unit length is 400 upon 40 centimeter. Centimeter to be converted into meter by dividing by 100. Then current is how much? Current is 0.4 ampere. So 0.4 is 4 by 10. And area is 2 centimeter square. So 2 into 10 to the power minus 4 meters square. Let us cancel the things, what all things can be cancelled here. 4 pi gets cancelled both sides. Then Two zeros gets cancelled here. One 4 gets cancelled here. Then 10 power minus 6 and 10 power minus 7. We'll take one 0 from here, and 10 power minus 6, 10 power minus 7 gets cancelled here. So here this side I am left with 1 mu r. Here this 4 is, we are left with this 4. This 10, this 2 is there, and 10 to the power minus 4 is there. So therefore mu r will be 10 power minus 4 goes that side, becomes plus 4. So 1000 upon 4 into 2. Just we can check it if we everything is okay or not. Yes, everything is okay. So we have 4 250s. So 250 by 2 is 125. So correct option is D. Then moving to the next question. The number of turns of a moving coil galvanometer is increased in order to increase current sensitivity by 50%. The percentage change in voltage sensitivity of the galvanometer will be. Now students, you know that in a moving coil galvanometer or suspended coil galvanometer, the coil is wound over a cylindrical drum, okay? And as soon as the current is made to flow through this coil, it gets twisted, thereby deforming this phosphor bronze wire, which in turn generates a torsional, you can say a torque due to torsion, which counterbalances this torque due to the magnetic field. Okay, so in that case, at equilibrium we can write like this: torque due to magnetic field, deflecting torque due to magnetic field is equal to restoring torque due to the suspension wire. Suspension wire, for now I'll write it like this. So this is torque is MP sine 90 degree, because magnetic field will always be at right angles to the plane of the coil. So MB sine 90 is 1, and this will be K times of theta, where theta is the deflection. N can be written as ANI into, okay. Now current sensitivity is the current required, sorry, the current sensitivity is the theta, that is deflection corresponding to unit current. Okay, deflection corresponding to unit current is, so that theta by I can be written as A N B by K. As you can see, in order to increase this, current sensitivity, number of turns can be increased, right? That is okay. Now coming to voltage sensitivity. Voltage sensitivity is nothing but the deflection corresponding to unit voltage. Now current is nothing but voltage into resistance of the coil. Sorry, voltage upon resistance of the coil. So what I can do is that theta, I'll write it like this: A N B K just a minute, students. This is voltage sensitivity. Let me write this as voltage sensitivity, and this will be voltage is I into R. So theta by I from equation 1 is A N B by K into resistance of the coil is rho L by A. This A is different, students, okay? Rho L by A. Okay. Now you can see if you increase the number of turns, automatically the length will also increase by the same factor. Suppose number of turns is made doubled. So automatically length will also be doubled. So accordingly, there is no change in the voltage sensitivity. So as you can see, the number of turns of the coil is increased. They are asking the percentage change in the voltage sensitivity. As you can see, the factor by which N changes, L will also change by the same factor. So that voltage sensitivity will remain constant. So no change means zero. Then moving to the next question. A long conducting wire having current I flowing through it is bent into a circular coil of N turns. Then it is bent into a circular coil of small N turns. The magnetic field is calculated at the center of coils in both the cases. The ratio of this kind of a thing. We all know that magnetic field at the center is given by mu 0 n I by 2r, where r is the radius. Now, if we can express the radius in terms of length, now you see length of each turn is this. If n is the number of turns, then total length of the coil must be this. So I can write 2r as L by pi n. So here mu 0 n I upon 2r. 2r will be L upon pi n. So we have magnetic field at the center is equal to mu 0 I pi upon L into n square. So you can see that rest all the things remain constant. Magnetic field at the center will be proportional to square of turns. So initially number of turns was n and then it is small n. So B option is the correct option. That's all, students, in this video. Thank you so much for watching my channel.